the linear system graphically, check your solution algebraically. Now if you look at this, unlike the previous example, these are not already in slope-intercept form. I think the quickest way would be to write them both in slope-intercept form, y equals mx plus b. But remember, we do have other ways, such as creating an input-output table and graphing intercepts. So if we were to write this first equation here in slope-intercept form, we're going to just solve for y. I'm solving for y, so I have to get rid of the 3x. So I'm going to subtract 3x from each side. These cancel. I'm left with y equals 11 plus a negative 3x. Okay, and I'll do the same for our second equation here. X minus 2y equals 6. So since I'm going to solve for y, I'm going to solve for my negative 2y first. So I'm going to subtract x from each side. My x's cancel. I'm not going to forget that that's a negative 2y equal to 6 plus a negative, I'm going to write 1 in there, 1x. Then I'm going to divide both sides by a negative 2. And the reason I want to do that is, again, I want y all by itself. Negative 2 divided by negative 2 is 1y. And then I'm going to divide each of these terms by negative 2. 6 divided by negative 2 is a negative 3. And a negative 1 divided by a negative 2 is just going to be a positive 1/2. And I'm going to leave that as a positive 1/2, not change it to a decimal or anything, because it's a coefficient of x. And I know that represents my slope. So let's look at our first equation here. Oops, maybe I can highlight it here for us. Make that red, and I'm going to copy that, because what we're going to do now is we're going to graph both of these equations on the same graph and see where they intersect. Oops. Try that one more time. There we go. Okay, so we have y equals 11 plus a negative 3x. Again, our slope-intercept here, our y-intercept is 11. So 2, 4, 6, 8, 10, 11. And our slope is a negative 3. So rise or run, I go down 3 and over 1. Draw a line through those 2 points. Again, using a ruler and extending your line in both directions is very important when we're solving by graphing. And even if your dots are a little off, really try to make sure it goes to the where the grid lines intersect. Okay, and then we're also going to work with the second equation here, which I'll just make blue for ease. This here. Okay, oops. Sorry about that. Get rid of my mess here. Okay. So in this case, our y-intercept is a negative 3. So on my y-axis, I go to negative 3 and plot that point. My slope is 1 over 2. It's already written as a fraction, so that means I rise 1, run 2. So from this point, I rise 1, run 2. Okay. Oops. Alright, so now looking at this equation, it doesn't look like they necessarily cross at a point. Now that's okay, but my piece of advice to you is if they don't, double check your line. Remember our first line here, we said our slope was negative 3 over 1. That means I go down 3 over 1, down 3 over 1, down 3 over 1. Do you see how my line is not quite going through all of them? That's my bad there. But if I fix it, Now it works a little bit better. I'm not telling you to move your line by any means, but what I'm saying is to make sure your line is drawn correctly. I've already said how many times. Make sure that it goes through, or you extend it and use a ruler. Well, also make sure that your points line up. The same thing is true for our second one. If our slope is 1/2, that means I go up 1 over 2, up 1 over 2, up 1 over 2. Okay, so if your line starts to veer off a little bit, you know that you should fix it. Okay, but truthfully, guys, it's okay if it doesn't lie in the perfect spot. But the majority of the ones you will do will line across the grid lines. So where they intersect is our solution. 1, 2, 3, 4 at the point 4, -1. Okay, so we are saying that our solution, our x and y value to this linear system is 4, -1. So let's double check that. I am just going to erase all this here since we've used it already. We said our solution was the point 4, -1. So let's plug this x value and this y value into our equations. Our first equation here, if we say 3 times 4 plus our y value of -1, that should equal 11. Does it? 3 plus 4 is 12. 12 plus a -1 is 11. So we know that point works. Again, what I'm doing here, you guys, is I'm just performing a check. I'm just making sure that this point is correct. Okay, let's look at our second point. Again, plugging this x and y value in because that is what we're doing here. We're solving the system. We're finding the x and y value that make both of them true. If I put 4 in for x minus 2 times a -1 equal to 6, we get 4. Well, if I go keep, change, I get -2 times -1, so that'd be plus a +2, and that definitely equals 6. So this point is true. It makes both equations true. So again, write them in a form that makes it easy to graph. Graph them, being careful that our lines are straight, that our lines follow the correct slope. The point at which they intersect is your solution, and double check that solution by quickly putting it into your equations to make sure you do get 2 true statements.